This is video number 6 concerning our series on Fourier analysis. A reminder, the playlist for all the videos is featured at our website, digital-university.org. Okay, in this video, we want to take a look at a sawtooth type function. Explicitly what we have is saying that f of x, when it's between minus pi and 0, f of x equals minus x. So instead of going in this direction, the graph goes in this direction. And then between 0 and pi, the function equals 0. So the total function is, it has a slant, and then it's 0. And then that pattern just keeps repeating like that. So the period for it then, we're going from minus pi to pi. It has a period of 2 pi. Now, in our formulas, we discussed these type of formulas in video number 1. We have 1 over L minus L to L, where L is essentially half the period. So the period is 2 pi, then L is pi. So here then we have pi divided by pi, so we'll just have the sine of nx. Now here we'll just have the cosine of nx. Now, again, the full period goes from minus pi to plus pi, but once we're past 0, when from minus pi to 0, it's minus x, then the rest of the function is just 0 throughout the rest of the period. So when we set our integrals up, we can just integrate then from minus pi to 0. So, and again, a naught would just be 1 over pi, 0 minus pi to 0 minus x dx. And since a naught is the simplest one to determine, let's do that right now. So, a sub 0 equals 1 over pi, and then we have the integral from minus pi to 0 of minus x dx. So let's just take the minus sign outside. So there's a sub 0. Put them side by side. This is 1 over pi. Now we're going from minus pi to 0. The function is minus x dx. So let's quickly find out what is a sub 0. So this will equal minus 1 over pi, and this will be 1/2 x squared. So let's just put a 2 here. X squared goes from minus pi to 0. So this will equal minus 1 over 2 pi, and then we'll have 0 minus, this would be plus pi squared. So multiplied through, this would be plus pi squared. Negative times negative, divided by 2 pi. That equals pi over 2. So a naught equals pi over 2. There is our first result. And again, we can think of this as like the average of the function. Okay, well now we've discovered what a sub 0 is. Let's work, see if we can find what a sub n is. So a sub n, that will equal 1 over pi. Now we're integrating from minus pi to 0 minus x times the cosine of nx. X, we'll put the minus sign out here. And again, this is the cosine of nx. Formula, of course, is cosine n pi over L times x. But for our problem here, L equals pi. So this is set up, obviously, to integrate by parts. You have one function times another function, and those kind of situations. The first thing you want to think about is integrating by parts. And the formula goes like this. And hopefully it's obvious that what we want to pick to be u would be x. This would be the u. And this part is dv. Because if it isn't apparent, hopefully it'll be in just a moment here, if u equals x, if we say let u equal x, then du equals dx. So we've gotten rid of the x. Now we say let dv that will equal cosine of nx dx. So v, the integral of cosine is plus the sine, so this will be 1 over n times the sine of n times x. So here then we have, just write down the integral first, and minus pi to 0 of x times the cosine of nx dx. That equals u times v. Here is u, and here is v. So we set it up like that, and we have x over, for u times v, we have x over n times the sine of nx. X goes from minus pi to 0. Then we have minus the integral of v du. So that's 1 over n. It's a constant. We take that to the outside. From minus pi to 0, the sine of nx dx. And actually we want to know what is minus 1 over pi times this integral. So minus 1 over pi okay, now here we put 0 in for x. The sine of 0 is 0. If we put negative pi in for x, the sine of any multiple of pi, whether it's positive or negative, is 0. So that's 0. So we have this is equal to 1 over pi n. And we integrate this. We'll get another n coming down here. So this will be 1 over n squared pi. We're multiplying two negatives here to give us a positive. The integral to sign is the cosine of nx with a minus sign before it. And we go from minus pi to 0. Okay, so this is that integral divided by minus pi is this expression. That's what a sub n is. So here we can say a sub n equals this. So let's see, a sub n equals minus 1 divided by n squared pi times cosine of 0 is 1 minus cosine of n minus pi. That's the same thing as the cosine of n times pi, because the cosine is an even function. And the cosine of theta equals the cosine of minus theta. The cosine of minus n pi is the same as this. And we encountered this expression in a previous video, cosine of n pi. That's minus 1 to the n power. Because when n is an odd number, the cosine of pi or the cosine of 3 pi or the cosine of 5 pi, that's negative 1. When this is an odd number exponent, this is negative 1. When n is even, cosine of 2 pi or 4 pi, that's 1. When that's an even exponent, that is 1. So we have then that a sub n is equal to this. 1 minus negative 1 to the n. Now, let's look at this. If n is even, that's plus 1. 1 minus 1 is 0. So for any even power of n, a sub n is 0. If n is an odd power, that's negative 1. We will have 1 minus negative 1. That would be 1 plus 1. That would be plus 2. So if this part here is either going to be in the parentheses, this is either 0 or 2, depending upon whether n is odd or even. So a sub n, that will equal either 0, and that's 2 times minus 1, so that's minus 2 divided by n squared pi. And this is for even n. Here, this is for odd n. So, then we determine a sub n, and let's say we already determined what a sub 0 is, so the last part of the puzzle here, a sub 0 is just pi over 2, so now we want to determine what is b sub n. We know this and this, now let's determine this. Okay, so this is 1 over pi. We're integrating from minus pi to 0. That'll be minus x Since that's pi, let's just do the sine of x, nx dx. So b sub n equals 1 over pi, the integral from minus pi to 0 of minus x times the sine of nx dx. So here we're going to have to integrate this by parts once again. Then when we do that, we'll determine b sub n. Then finally we can put all the pieces together and get our formula. We're kind of going to get up against a time limit here. Let's do this. Let's stop the video right here. Come back, join us in the very next video, and we'll solve this integral, determine b sub n, and finally we can get our expression. So come back, join us in the next video, and we'll finish off this problem.